meant to figure out if this system of equations is equivalent to a system that could be put in augmented matrix form. Now, the only things that can be put in augmented matrix form are systems of equations that are linear. And I see some nonlinearity here, this x on both sides. I guess if I could cancel the x's, this x and this x, then I would have a system of linear equations. But I can only do that if x is not 0. So let me see what I can do. I'm going to put those two equations together and say that this is equivalent to either a pair of equations where x is equal to 0 or some system of equations where x is not equal to 0. I'm going to make these different cases and see what happens. If x is equal to 0, then that first equation is trivial, right? It just says that 0 is equal to 0. And the second equation, the second equation would be 2 times 0 plus y is equal to 0. So that actually would be y is equal to 0. Okay, so in the case where x is equal to 0, the system of equations simplifies to that. And that's certainly a linear system of equations. If x is not 0, then we also get a system of equations. We also get a system of equations. Interesting. Let's take a look at the system of equations that we get if x is not 0. Then I could cancel these two things. Let me just move everybody to the same side. Let's see. 2x, I move it over there, and that'll give me 3x's. 3x, and then the y, if I move that over there, I'll get negative 2y. And then that would be equal to 0 because everything would have been moved over. I'm imagining this equation with the x canceled on both sides. And then 2x plus y is equal to 0. Okay, so either this or this. We can get a solution out of this or this. Now, let's see. The question of whether this is equivalent to a system that could, a system of linear equations kind of rests on whether or not this linear equation, this system of linear equations are the same. This right here might be incompatible with x being 0, right? This system of 3 statements might not have any solutions. This definitely has a solution. So let's keep going. I'm going to group those all together and say that that's equivalent to, well, the first condition, x is equal to 0 and y is equal to 0. Or the second is x is not equal to 0, and what can I do? I'm going to add 2 times the second equation to the first, so 3x's plus 2 times 2x, and that's going to give me 3x's plus 4x's is 7x's. And then negative 2x's plus 2 times y, that'll give me no y's. And on the other side, 0 plus 2 times 0 is 0. And, oh, you know what? Right away, I see that this equation right here says 7x is equal to 0. So I'm going to just first, be the sake of being complete, I'm going to write 2x plus y is equal to 0 here. Just recopy that previous equation. Now, notice that this system right here, this system of 3 statements, that's incompatible. You can't have that x is not 0 and 7 times x is equal to 0. So there are no solutions to this system of 3 statements, but there is a solution to that. So in the end, this is equivalent to simply the system x is equal to 0, y is equal to 0, because there's no solutions to that. And that is equivalent to the augmented matrix 1, 0, 0, 0, 1, 0. Okay, so the answer is yes, the system is indeed equivalent to a system that can be put in augmented matrix form. And that hinged on us only having just the one solution that came from assuming that x was 0. If we would have found that down here there was some other solution, well, then we probably wouldn't have been able to say that the system of equations was equivalent to a system of equations that can be represented as an orthogonal matrix.